Hi guys, my name is Fahad and welcome to Electronic Clinic. If this is your first time here and you want to learn Arduino programming, PLC ladder logic programming, SCADA application designing, SolidWorks, Visual Basic application designing and programming for microcontrollers to send and receive data, Android, security systems, robotics, image processing and much more, start now by subscribing and clicking the bell icon so that you never miss anything. So my friends, first of all, download 2.4.10.1940 version of the MGO-CV and then just simply install this. You don't have to make any changes, just you have to click the next in the green button and that's it. Now as it's gonna take some time, so I will fast forward this. So friends, now we are done with the MGO-CV installation. Now it's time to do the MGO-CV settings. So for that, first of all, we will have to open the VB, the Microsoft Visual Basic 2010 Express Edition. So double click Visual Basic 2010 Express and then click on New Project and make sure that you select the Windows Forms application and OK. So the first step is to click on the project and add references. Click on the browse, C, MGO, bin, and select all these DLL files. Now hold the shift key, select these DLL files and click OK. So after this, C, MGO, bin, and now select this, the x86. Okay, so click over here and now select all these DLL files, hold the shift key and now click over here and select copy of newer. Okay, now again, now this time you have to click this, drag, okay, now do same for this, select this, hold shift key and if newer. So now we are done with the MGO-CV settings. You can see the references are added, the test data is added, the x86. So we are done with the basic settings. Now we will discuss circuit design. So my friends, this is the complete circuit diagram and this is designed in Ksoft Eagle 6.3.0 professional version. If you want to learn how to make schematics and how to design your own PCBs, then you can watch my tutorials. So my friends, as you can see, the circuit diagram is really easy and it's very self-explanatory, but let's discuss. This is an electronic lock. If you want, you can use any other lock, or you can use even a servo motor or some stepper motors or DC gear motors to open and close an entrance. But in this project I'll be using the electronic lock to demonstrate how I can actually open an entrance
by detecting a human.
So as you can see, the electronic lock has two wires, and so the one will be connected with the plus 12 volts as you can see, and the other one will be connected with the normally open of the relay, and the other wire will be connected with the relay common pin, and then it will be connected with the ground. So the supply to the electronic lock will be controlled with the help of this relay. So when we turn on a relay, this contact will connect with this one, and then the path will be completed and the electronic lock or the entrance will open, and then we can just close that when the contact connects again with the normally closed. So, and how it works actually, as you know, that it's a 12-volt electronic lock and it cannot be directly controlled using microcontroller. So for that we will have to design a driver circuit, and this is a relay driver circuit. So this relay will be controlled with the help of this transistor, and this transistor will be controlled with the help of a 5-volt signal from the microcontroller. Now the selection of this NPN transistor actually depends on the relay coil current. So first of all, we find the relay coil current by simply measuring the resistance of the relay coil, and then using the formula V is equal to IR, and then as we know that's a 12-volt relay, so then we use the formula V is equal to IR, so 12 equals to I into the resistance of the relay, and then we can find the current. So you can use any NPN transistor so far its collector current is greater than the calculated value. Well, I recommend you should go for the 2N222 transistor because it's very cheap and easily available in any electronic shop, and moreover its collector current is greater than 600 milliamps, which is best for controlling relay. Even larger relays can be controlled using this transistor. So now over here you can see a 10K resistor is connected with the base of the 2N22 transistor, and the emitter is connected with the ground, and the collector of the 2N22 transistor is connected with one coil pin of the relay, and the other pin of the relay coil is connected with 12 volt. So when the transistor is turned on, it will go into saturation. Saturation means that the emitter and collector are short. It acts as a one wire, so the 12 volt is coming from here and the ground will be coming from here, so the relay coil will be energized and it will turn on. So and you can see that this will be connected with pin number 13. So actually we will be controlling this lock using pin 13 of the Arduino Uno, and then we will send a signal from our designed application that will send a command to the Arduino controller, and then the Arduino will act accordingly. It will open or close the entrance. So it's going to be a very fun kind of project. And now let's start soldering and discuss about the electronic lock. So this is the electronic lock that I will be using today, and well, actually I don't need this, so I will cut this and connect a DC socket so that I can easily power this up using a 12-volt adapter. So now let's connect the DC socket. Okay, now our DC socket is connected, and now let's check this. Okay, this is 12 volt and it's working just fine. Now let's start the relay driver circuit. It's a VRA board and it is an SPHD relay. Now let's solder this. This is an NPN transistor, and the leftmost pin is the emitter, the middle one is the base, and the rightmost is the collector. And this is a 10K resistor, and I'm connecting this with the base. Okay, now the next step is, now I will connect the collector of the 2N22 transistor with the coil pin of the relay, and the emitter I will connect with the ground. So once I do these connections, then I will be back and explain this. So okay, now all the wires are connected. This is a 10K resistor which is connected with the base of 2N222 transistor, and this is the emitter, and this one is the collector. So as you can see, the collector is connected with one side of the relay coil. Okay, and the other side is connected with the positive, and the ground wire is connected with the emitter, and there is another wire which will be connected with the Arduino ground, and this wire is coming from here and which will be connected to pin 13 of the Arduino. Through this wire we will turn on and turn off this relay. And there are two more wires, this one and this red wire, the blue and the red wires. So blue wire is connected with the common of the relay, and this one is connected with the normally open of the relay. So we will connect, so these are the two wires to which the electronic lock will be connected. So now I will do the interfacing. So my friends, as you can see, all the components are interfaced. This is the electronic lock, and these are the two wires of the electronic lock. So it is connected in series with the relay, with the two wires which are the blue and the red wires. So we will be giving 12 volt over here for the relay, as it needs 12 volts, and another 12 volt we will give over here for this one to energize this. So supply to the electronic lock will be controlled with the help of this relay. And you can see the white wire is connected with pin number 13, and this another one is the ground wire, which is the black wire. So that's the interfacing. So my friends, this is the programming, which is extremely easy, and we start with declaration, that is integer elock equals to 13. Well, you can give it any name, but as you know that the name should have some meaning. Like for example, from this name it's quite clear that it's an electronic lock. So, and you also know that all the variables has some rule, like for example at the beginning we cannot use numbers, and the spaces are actually not allowed, it will generate an error. So make sure that you don't use any number in the beginning or spaces. So integer elock equals to 13, as in the circuit designing I told you that the electronic lock will be connected with pin 13 of the Arduino. And then there is character data. So as we will be doing serial communication with the computer, so for that we need a variable which can be used to store that command or that character which is coming from the computer. So then as you know, my friends, that every Mega and Arduino Uno program has at least two functions, which are the white setups and white loops. So we start with the white setup, and as you can see over here, white. So white means that this function is not returning any value, and the empty parentheses means that this function is not taking any arguments as the input. So we start with the pin mode elock output, as you know that the electronic lock is an output device, so that's why it's output. And as we will be doing serial communication with the laptop, actually there will be serial communication between the laptop and the Arduino, and for that we have to define the communication speed, which is 9600, and that this is called the baud rate. So we activate the serial communication by using this function serial.begin, and this is a function, as you can see the parentheses, and it takes one argument, and which is the baud rate, and that is 9600. If you want, you can use any other baud rate. And digital write elock low, so we keep the electronic lock low by default. Then starts the white loop, it's also not returning any value, and it doesn't take any arguments as the input. So if serial.available greater than 0, so it means that if there is any data received from the computer, or if there is any data available on the serial port, then what to do? Data equals to serial.read, then read that data and store that into data. So if data equals C, if you have received a character C from the computer, it means that open the door, or open the entrance, or open the main gate. and if data equals D, then close the entrance. So that's a very simple program. You can download this code from my Blogger page. I will provide the link in the description. And now let's connect Arduino, and so my friends, now the Arduino is connected. As you can see, we're here, serial port, and it's on COM8. And now upload the code. So friends, the program is uploaded, and now we will start the application designing and then the programming, and then we will test this. So let's start the designing. So friends, as we already did the MGO CV setting in the beginning of this tutorial, now it's time to design the basic application. So for this, let's first of all arrange this form. Now toolbox, we will need a picture box over here. Double click, and now drag, click over here and select center image. Okay, that's it. And now we will need about 5 labels. So tools, so here's label 1, label 2, label 3, 4, 5. If you want, you can also change its name, like let's keep its name LBL face detect, and face detect. We will also need a button, so double click, use it over here. Okay, we will also need 3 timers and a serial port, as we will be doing serial communication with the Arduino. So for that we will need a serial port. So double click, and now we'll be needing 3 timers. So click, click, and click. So 3 timers are added. Now make it true, and that's fine. Okay, and now for the timer 2, it's true. Make it true, and change this to 5000 milliseconds, which is equal to 5 seconds. And let's keep this false by default, and let's make it 1 second. So this is our basic form, and if we click on the play, so as you can see, it's not doing anything because the code is not yet added. So now we'll start the coding, but before that, first let's change its name. So over here you can change like image processing based entrance control system. Okay, so now time to start the programming. So friends, as you can see, the form designing is completed, and to keep the tutorial time under 40 minutes, I've already added the code. So double click on the form, and as you can see, this is the complete code of the project, which is easy. So let's discuss this. We start by importing these libraries. So imports MGO .cv, imports imgu.cv.util, imports imgu.cv.structure, imports system.diagnostics, and imports system.io, which is for the input output, and imports system.io.ports, and imports system.threading. Well, if you want to study about the imgu.cv and all and about these libraries, so you can just make a search on Google, and there are a lot of information available about these libraries. Then public class form dim, we just define some variables, and we are using these variables as boolean. So dim face detected as integer, dim face present as integer, and dim detect time count as integer. Then we start with dim web as capture is equal to new capture 0. Now if you are using external camera, then you can simply change this number, for example 1, 2, 3 or 4. So right now I'm using 0, so as I will be using the laptop default webcam. So then for the timer 1, if you open the form and click on the timer 1, so as you can see over here, we are using a function over here. Okay, so then this is the function dim photo as image of bgr byte, then photo equals to web dot retrieve bgr frame, dim current center as new point, this is a function, and then dim face detection is new cascade classifier. So when you start the programming, first make sure that you make a folder with the name data in C drive, and then inside the data you make another folder with the name har cascade, and then in that folder you just copy this XML file, which is the har cascade frontal face default, as we will be using this application for the human detection, for the human face detection. So we will be needing this XML file. Let me show you this. As you can see over here, this is a C drive and with name data, a folder with the name data, and then double click this and you can see over here this har cascade, and then over here you can see the har cascade frontal face default. Face detected equals to 0, so by default we keep this 0. Later when we detect a face, then we will make it 1. So try dim image as image of gray byte equals to photo.convert of gray byte. For each face is rectangle and face detection dot detect multi-scale image 1.1. so actually you can play around with these values 1.1 and with this 8 for the best result. So and then photo dot draw face new bgr color dot white, so when a face will be detected, then we will make a square around it. So we can also change the color and the line weight. So now the current center dot x, so when the face is detected, then we will find its coordinates, the x values and the y. So these two instructions for that purpose. Then label 1 dot text equals to center dot x dot to string, then we will convert that to string and display the x and y values on the label 1 and label 2. And then we write this instruction, and then after that photo.draw human detect and add scanning. When the human is detected, then with the box it will be written. And then similarly for this one, and this is for the human detection. Okay, and then label 3 dot text is equal to face dot to string, and face detected equals to 1, so that the face is detected, so that's why we make it 1. And then picture box 1 dot image equal to photo dot to bitmap catch ex as exception and end try if face detected equals to 1. So as in the beginning we set it to 0, so when it is 1 it means that a face is detected, then it will start the scanning, and then timer 3 dot enable is equal to true, and then the timer 3 will be enabled and it will start counting. Else LBO phase detect.text is equal to no human if there's no one in front of the camera. If no human is detected, then label3.enable is equal to false. It will be false automatically, and detect time count equals to 0. Set the time count to 0 and face present equal to 0 so that the face is not present, and then end if. So if detect time count greater than or equal to 3, then what to do, that serial port 1.open. First of all, we open a serial port, and label4.text is equal to human detected, and then we send C to the microcontroller to open the entrance, and then we close the serial port. And this is the form1 load for the serial port settings. So first of all, what we do is serial port 1.close, then we set the name COM8 is my Arduino is installed on COM8, so that's why it's 8, and the baud rate is 9600, which already discussed in the controller programming, and the data bits are 8, and the parity is none, and the stop bit is 1, handshake is none, and the system.text.encoding.default. Now for the timer 3, actually detect time count equals to detect time count plus 1, and label4.text is equal to detect time count. So you will see this in action once we will be running this project. And for the timer 2, serial port 1.open, send D. So this is in case if there is no one in front of the camera, no human in front of the camera, then it will send D to the microcontroller to close the entrance. And if you want to manually open the door, so then you can use that button to open the door and button 1. So that's the complete programming, and I will provide a link in the description so that you can download this code from my Blogger page. And now let's see this project in action. So my friends, now let's run this application. Let's minimize this. And my friends, as you can see on the screen, the Arduino is already connected with a laptop through a USB cable, and I have connected 12 volt source over here and another one over here. So currently I'm using two 12 volt adapters. If you want, you can also use a battery as a source to supply 12 volts to the circuit. So as you can see, currently there is nobody in front of the camera, so that's why it's not doing anything, because this application is only designed for detecting the human face. So the electronic lock will be opened and closed only if it detects a human face. So currently you can see the door is in closed position, the entrance is, you can see, and now let me in front of the camera. It has detected me, and now it will start counting 1, 2, 3, and boom. So the door is now open. So now I'm not in front of the camera, so the door is enclosed. So let's try again. And again it start the counting so as to avoid the false triggering. So my friends, that's all for now. So I hope you like today's episode. Like and share my videos with your friends, and also watch my other tutorials on image processing, and subscribe to my channel so that you never miss any of my upcoming tutorials on image processing and security systems and Arduino programming, SolidWorks. And thanks for watching.